Hello, my dear old students. I hope you are doing well. This is our first week of this semester, and in this week, we are trying to know about two methods. One is Newton's forward interpolation, and another one is Newton's backward interpolation. And this is applicable for maths. So we need to understand the forward interpolation and backward interpolation properly so that we can do our maths or so we can do our sectional class very easily. Okay, now let's start. At first, I would like to discuss about Newton's forward interpolation. Okay, what is actually forward difference or forward interpolation? Um, the differences between y1 minus y0, then y2 minus y1, and in this way up to yn minus 1. That means the next value is subtracted from the previous value, which is called the set and the difference of y. Denoting these differences by del y0 for y1 minus y0, del y1 for y2 minus y1, del y2 which is for y3 minus y2, in this way up to del yn minus 1 respectively. Okay, this is very easy, and del is the notation of forward difference operator or forward interpolation or forward differences. Okay, now for higher order differences, we have del square y equals to del y1 minus del y0, then del cube y naught equals to del square y1 minus del square y naught in this way. And the formula for Newton's forward interpolation are given below. Okay, now there is an example given for you. And for this example, we have to find out Newton's forward interpolation or forward differences table. The given value is that the population of a town and the um, population of a town in a specific year, and you have to find out the population of this town in the year of 1895, which is not given here because you can see that the population of a specific town is given, which is 1891, 1901, then 1911, 1922, 1931. But you have to find out the population of this specific area or this specific town, which is 1895, which is not given here, and you have to remember that what's the question is. The question is that you have to find out a specific here which is in between the range. That means that the starting year is 1891 and the ending year is 1931, and you have to find out 1895, which is in between this range. Okay, now let's start. First, you have to find out the value of h, which is 10. We can what is the value of h? The value of h means the um, difference between or interval between the population in thousands, these rows. So oh, sorry, 1 minute. The h value is the difference between the year, which is the value of x. That is if you count x not equals to 1891, then x1 equals to 1901, then x2 equals to 1911, then you can find out h, because here is the difference between x1 minus x0, which is 10. And you have to careful about that. The difference between each year or each 2 year are equal. Now you have to find out the value of u. How we find out the value of u? We find out the value of u by this way. That is x1 minus x0 divided by h. Then we can get the value of u. Uh, so what is the value of mm, So the value of x equals to your required year, which is 1895, and the value of x not equals to 1891. So we find out the difference between these 2 years, and the given value or the finder or the required value is divided, and the required value is divided by interval, and we can get our u value, which is needed for our forward interpolation. And now we construct the difference table by the following way. This is the outlook of a Newton's forward interpolation or Newton's forward difference table, where you have seen that the first two column is the year and population, which is denoted by x and y. Then we find out the difference between del y, then del square y, then del cube y, and del to the power 4y. Uh, Up to when we terminate the table, or when we stop our calculation, when we just get one single value, that time we just terminated our program, or we just stop our calculation. So at first we have to find out del y, which is the difference between y1 minus y0, which is 20. 66 minus 46, we get 20. Then the next value is 81 minus 66, which is 15. And in this way we can get our solution. And we already have a forward interpolation equation, which is y0 plus y u del y naught plus u into u minus 1 divided by 2 factorial del square y naught, in this way up to del to the power 4y. Why we counted del to the power 4y? Because of our table stopped in this situation. If our table stopped in del to the power 5y, then we add just one portion, which is u minus u into u minus 1, then into u minus 2, into u minus 3, into u minus 4, divided by factorial 5, and multiplied by del to the power 5 y naught. Okay, clear? Okay, and finally we get our result, which is 54.853 thousands, and we get our desired result in the specific year, which is 1895. The specific situation, the specific town has a total 54.853 thousand people approximately. This is your approximation value. This is not the exact value. Okay. Okay. I think all of you clear the math. All of you have a clear idea about this method. Then we need to count a backward interpolation, which is as similar as forward interpolation table. And we need to count the same way, in the same method, but for backwards interpolation the equation is slightly different from forward interpolation. In forward interpolation we use all negative signs, that means for third iteration, which is u into u plus 1 for backward interpolation, but in forward interpolation, which was u into u minus 1. And in this way all the minuses were put there. And for calculation of u, we just find out which is also different from a forward interpolation. And the equation of u is x1 minus x minus xn divided by h. And h is what? H is the difference between two values of x. Okay, now let's start. This is the equation, or this is the given problem for you, where you can see that a table is given for you where two rows x and y, and the sum values are given here, and you have to find out the value of x equals to 63 by for backward interpolation. And the 63 is also in between the range, that is 45 to 65. And you also notice that in the forward interpolation we find out the value of a specific here which is near closer about the first value, and in backward interpolation which value we find is actually closer to the end of the value. Okay, now let's start. At first, we have count our age and u, and for age, you can see that mm, 45 minus 50 or 50 minus 45, which is the value of x, and u is xn means last value 65, and x means the given value which is you have to find out which is 63. And h you already know, so you can get the value of u. And when we get the value of u and h, we can easily find out the value of for backward interpolation. Okay, and this is the table for backward interpolation. uh, The style of backward interpolation is slightly different from the forward interpolation, and the equation is already you know. Uh, okay, now go to our next slide, and what you can see. You can see that you can find out the value of 63 by using backward interpolation, which is 70.56816, and you must have to write um, approximately worked. This is because this is the approximate solution, not the exact solution. Okay, thank you. Before I end my class, I want to say something. Uh, as this is a big lecture, and you can see that we can find out two uh, two equation, or two we can solve it two equation by using forward interpolation and backward interpolation. But in the both cases the difference, that means the h value is equal, that means the interval are equal. And in this situation, this is called equal interval forward differences and equal interval backward differences. But there are some situation may arise where you can see that the given value, the interval are not equal. Okay, we will solve this type of problem in our next class or next upcoming classes. Okay, thank you all, and bye bye for today.